In this video, I am going to explain about the properties of alcohols. So far we have seen in the previous video about the preparation nomenclature. Now we'll see the properties. And the properties have been divided into two categories. First is physical properties. So, alcohols are liquids. All the alcohols are liquid. They are colorless liquid. So, they are colorless, sweet smelling liquids. They have sweet or they have pleasant smell. They have sweet smell, and they are volatile in nature. Means they are converted into vapors very easily. They are very, weak tendency to hold together. So they have very strong escaping tendency. All the organic liquids, they have a strong escaping tendency. They escape from the surface very easily due to poor force of attraction. That's why they are highly volatile. They have high boiling points. They have high boiling points than that of alkanes and other hydrocarbons. Other hydrocarbons means the derivatives, means from other compounds and form hydrocarbons, and is due to the strong hydrogen bonding. They have hydrogen bonding. Alcohol molecules, they are bonded together. Like this is one alcohol. So if there is other alcohol, so there can be formation of hydrogen bonding. So this is H bond. So due to hydrogen bonding, the force of attraction between the molecules is very strong and so. Then there is the solubility. Alcohols are highly soluble in water. Alcohols are highly soluble. Means they are easily soluble, highly soluble in water, and is due to formation of hydrogen bonding. Hydrogen bond is formed very easily. So anything is able to form the hydrogen bonding will be soluble easily. Like ionic compounds. Ionic compounds, they don't form the hydrogen bond in water, but the force of attraction between the ionic compounds, ionic molecules, they are broken or they become weak, and so this is there. Now coming to second, chemical properties. So alcohols are versatile. Alcohols are versatile or dynamic substances. They can react with different substances in different manner, and this is called dynamic or versatile nature. And it is because, see here, if I write here ROH, here if the cleavage, this breaking is called cleavage. If the cleavage between this, more precisely here I write like this, between C and O. This is C and this is O. So here it acts as base. It acts as base. Negatively charged is ions are produced, and here it act as nucleophile. This is very important move. It acts as nucleophile. This OH will attack on the positive center. So it will act as nucleophile. So this is the one category. So here it acts as nucleophile. Now coming to second category, here just I am writing here. Here if cleavage takes place between O and H. Cleavage means what? Breaking. Cleavage between O and H. So here there is the release of what? Release of HI. So here it acts as electrophile. Means it can attack on the negative center. Can attack on negative point. Here can act on positive point. So this is the meaning of this nucleophile. This nucleophile or this nucleophile. Here it is, this is electrophile, and so we can have this. So this is the reason behind that alcohols are versatile or dynamic in nature. So we will study in two categories here. So as base and here as an acid. So this is divided into two categories. So we will discuss step by step. Now see, you take any alcohol. So alcohols, they react with metals. So this is reaction of alcohols and acids. So it will, reaction with metals. Not all the metals, but alcohols react with active metals like sodium, potassium, calcium, and there is the release of hydrogen gas, colorless, odorless gas comes out. And here there is, if you take this is ethanol, and this is sodium ethoxide. So this is there, and when reaction between metal and acid takes place, there is release of hydrogen. So it means this justifies that alcohols are acidic in nature. Now coming to important point, what is the reason behind the acidic character of alcohols? Actually, alkyl groups are electron donating groups. They are electron donating groups. They push the electrons. So here this is, primary alcohol. This is primary alcohol. This is secondary alcohol. And here it is tertiary alcohol. So see here, there is one alkyl group. So it will push the electron towards this carbon. And so this bond, this bond between this, if I write here like this bond becomes weaker. Bonds are always weaker depending on the groups attached, and so there's the loss of HI. See carefully. In case of secondary alcohol, there are two electron donating groups or two. This is the one group, this is the second group. So what will happen? The electron density pushed on this carbon will be more. Electron given by these two alkyl groups will be more. And so here, if I write here again, this bond will be stronger. This bond will be stronger. And the tendency to lose the H ions, H ions decreases. Here in this tertiary alcohols, there are 3 electron valence groups. So this bond will be very strong. This bond will be very strong, so poor tendency to lose H ions. So what is the trend? How we can conclude? What is the conclusion? That on moving from primary to tertiary, the acidic character decreases. There is decrease in the acidic character. However, alcohols, they are less acidic than water. You can keep in mind, alcohols are less acidic than water. Now, if I write here water, so it has, lone pair of electron. So it will gain this if it is there. It is acting as base, so it will be able to attack here. And as a result, there is formation of CH3OH, and plus this ion will be, there is the release of this ion, and so as a result we can say there is formation of an acid. There is formation of, from this water, this conjugate base, and so this indicates that alcohols are less acidic than water. That is, water is a stronger base than acid than alcohol. Alcohols are less acid. Water is more acid. This is in terms of Lewis acid-base concept. Now coming to next very important part, esterification. So esterification is the formation of ester. So it is defined as formation of an ester by reaction between an acid and alcohol. Acid and alcohol, there is a reaction. So here this is, ethanol. So esterification can be carried out in presence of this is acetic acid, and here we take this concentrated sulfuric acid, concentrated H2SO4, few drops, and we warm in water bath. As a result, there is formation of this. This is ester. This is ethyl-methyl ester. This is ethyl-methyl ester. And this reaction is basically, it is reversible. That's why it is concentrated sulfuric acid is heated, taken, and it is warmed. Then this is anhydride, acetic anhydride. This is ethanoic anhydride, and again the same reaction takes place. There is the formation of this, plus 2 moles are formed, plus there is the formation of water. So there is this is ester, again same is formed. This is acid halide. This is ethanoyl. This is ethanoyl chloride, and again the same reaction. CH3CO C2S 5 plus HCl. The product remains the same, but you have to keep in mind that in esterification, the most preferred product is CH3COOH. This is most preferred, followed by this CH3CO called twice O, and then CH3COC. So this, this is the best way. This is the best way. Most preferred esterification agent. Why? Because it is least reactive. Carboxylic acids are least reactive, and as we go, reactivity increases, and when the reactivity increases, what happens? Reactions cannot be controlled. So it is easy to control this reaction, and so this is the esterification. Now we'll see trans esterification. Trans means beyond. So trans esterification is a special type of esterification in which one ester is converted into other ester by changing the alkyl group. If I write here, this is methyl ethanoate, alkyl name, and it is called as dimethyl ester. And in this, we take this ethanol. Same condition, we have to warm it, and there is of course few drops of concentrated sulfuric acid. The reaction, it is reversible, so we take few drops of concentrate, just few drops, to absorb the water formed in the reaction, and so the result CH3, COO, C2H5 plus there is CH3 OH. So this is methyl ester. Methyl ester. This is IUPAC name. This is the common name. IUPAC name. This is ethyl, and this ethanoate. This is ethyl ethanoate. So methyl ethanoate can be converted to ethyl ethanoate by changing this. So this is very important to note that an ester can be converted to other ester by changing the alkyl group. Now I am going to explain second part. It is reaction as a base. So first reaction with hydrogen halides. Hydrogen halides, HX, HCl, HBr, HCl. So very simple reaction. Any alcohol, when reacts with any hydrogen halide, there is formation of corresponding haloalkane. Corresponding haloalkane is obtained. This is very important point to note. And this is way to prepare the alkyl halide. So alcohols, they are reactive in nature. But the three different tests of the alcohols, they are not having the similar reactivity. Once again I am repeating, all the three categories, primary, secondary, and tertiary of alcohols, they are not equally reactive. You know this. And this reactivity is due to the difference in the alkyl groups. Primary has only one electron releasing group or electron donating, secondary have two, tertiary have three alkyl groups to provide electron. So it is distinguished. Alcohols are distinguished on the basis of Lucas test. Lucas was a scientist who had invented this test, and this is called as Lucas reagent. Lucas reagent. And what is Lucas reagent? Lucas reagent is a mixture of concentrated HCl and anhydrous zinc chloride. Anhydrous zinc chloride, this mixture in equal amounts. Now what happens? There is reaction, there is HCl, HX, so there is formation of haloalkane. So when you take primary haloalkane, no reaction takes place. There is no reaction takes place. Primary alcohol, no reaction takes place. Secondary, after some time, this type of reaction here, if you write here, let this be any alcohol, secondary alcohol. So here we may write here ROH to distinguish, and so here we write here RBr, haloalkane, and so here there is no reaction takes place with the primary alcohol because the primary alcohols they have only one electron ranging group, and so there is no reaction takes place to form the haloalkane. But secondary haloalkanes they are formed because of the decreased reactivity. Just it's the opposite of the reactivity nature of the alcohol. So secondary alcohols they form the haloalkane. They form here there is no Rx. Here there is formation of haloalkane after some time slowly because it has two electron releasing groups, and then so slowly reaction takes place. In case of tertiary haloalkanes there are three electron releasing groups. So three electron releasing groups are present, and there is the increased electron relating groups. Electrons are more released, and so this is very important test to distinguish between the primary, secondary and tertiary alcohols. We can distinguish primary, secondary and tertiary alcohols. Here no haloalkanes are formed. Here there is a formation of actually turbidity. Turbidity means something it becomes slightly opaque. Turbidity appears. Like if we add a drop of milk in a cup of water, it becomes slightly opaque type. So that is called turbidity. So if there is formation of turbidity after some time, in case of tertiary immediately, primary no turbidity. So this is very important test to distinguish between the primary, secondary and tertiary alcohols. Now moving forward, some more reactions. So it is reaction with phosphorus trichloride. So you have seen in the previous chapter. So there is the reaction between alcohol, any alcohol and PCl3. There is formation of corresponding haloalkane, and this H3PO3 is obtained. So it can be same with the PCl5. So PCl3 and PCl5 they are same product. Then very important is dehydration. Dehydration is loss of water. So when we take any alcohol, it starts from the ethanol. Methanol cannot be dehydrated because it has only one carbon. So we heat at this specific temperature. Temperature has to be kept. It has to be mentioned. We take concentrated sulfuric acid and heat. There is formation of ethene plus water is produced. So it is called as dehydration. But actually dehydration it follows different trains. Dehydration follows different trains in primary, secondary and tertiary alcohols due to their reactivity. See how. So the three different alcohols they have different degree of dehydration. This is secondary alcohol. This is tertiary alcohols. So the degree of dehydration increases. It is easy to dehydrate the tertiary alcohol. See, primary alcohols, primary, suppose I write here CTS5OH, and here we take the concentrated sulfuric acid, and we have to heat at 443 Kelvin, concentrated, and then there is formation of this ethene plus water is produced. So this concentrated very strong acid. But when we take secondary alcohol, 85% phosphoric acid, and it is 440 Kelvin. Phosphoric acid is very weak acid. Phosphoric acid is very weak acid. It is used in cold drinks for flavoring. So phosphoric acid, there is formation of this alkene, corresponding alkene. If you take tertiary alcohol, then here it is 85%. But if you take tertiary, there is 20%. 20% alcohol, 20% this phosphoric acid, and temperature is very low, 358 Kelvin. And so again there is formation of alkene. So this indicates that the tertiary alcohols they can be dehydrated easily, followed by secondary and followed by primary. So it is easy to dehydrate the tertiary because of the presence of three electron releasing groups. So this becomes very weak. and one is from this, one is from this, so it releases. So this is there. Again, if we want, so this was CS2 and H, and so this. So this is very simple, and we'll see the mechanism. Now coming to very important mechanism of dehydration. How alcohols are dehydrated to form the alkene. So this is divided into three steps. This first step, it is protonation. This is called as protonation of alcohol molecule. Oxygen has two lone pair of electrons, so this acid attacks on this, and there is mention of this is oxonium ion or ethyl oxonium ion. This oxygen carries the positive charge. This reaction is reversible. Oxygen has positive charge, so it is very unstable. It is not stable. So second, it very quickly. This is also reversible reaction. So it loses water molecules very easily, and there is mention of carbonium ion. Carbonium ion, carbocation. Then as carbon has positive charge, it cannot be stable. So it very easily, very quickly loses proton, and there is version of alkene. So this is the mechanism of the dehydration of alcohols to form the alkenes. Now moving forward, very important, oxidation of alcohols. Alcohols are quite reactive, they are volatile in nature. So three different grades of alcohols, primary, secondary, and tertiary, they respond differently in terms of oxidation. So here, if there is primary alcohol, so primary alcohols are oxidized to form the corresponding aldehydes. Corresponding aldehyde is, so primary is converted to aldehyde. Secondary alcohols behave in presence of K1F4, or we can take potassium dichromate. So oxidation can be in presence of K1F4, K2Cr2O7. There is the requirement of moderate oxidizing agents. We don't use any acid as such. So here there is formation of secondary, there is formation of RCOR. This is ketone. But tertiary alcohols, this is secondary, this is tertiary. Tertiary alcohols are quite resistant towards the oxidation, and they cannot be oxidized. But if we take a strong oxidizing agent like chromium trioxide, concentrated sulfuric acid, so instead they undergo oxidation, rather they undergo cleavage. They go cleavage, and there is formation of this mixture of carboxylic acids, and there is but the number of carbon atoms remains same. Here see 1, 2, 3 and 4, 1, 2, 3 and 1, 4. Mixture of carboxylic acid. We have to take the strong oxidizing agents, because they are stable to oxidation. So this is very important point to note. Now other we'll see about the catalytic oxidation. See, now this is very important type of oxidation. When we pass the vapors of alcohols, because we are heating at very high temperature in presence of copper, or the same on passing the vapors of alcohol through red hot copper, the same, because temperature is very high, 573 Kelvin, so copper will be red. So this can be same. So reaction will remain same. Catalytic oxidation, this primary alcohol, it is converted to aldehyde. Secondary alcohol, it is converted to ketone as same. But tertiary alcohols, when same reactions are taken, then they are resistant towards oxidation. This differentiates that the tertiary alcohols, they are resistant towards the oxidation, and instead they undergo what? They undergo dehydration. They lose water molecule and there is formation of alkene. So this is very important to note that this test can be used to distinguish between the three in terms of chemical test. So this is all about the chemical properties of alcohols.